Hi everyone, I am Ingest Microsoft MVP. Today, I will share with you about stream analytics and machine learning. For case study, in a series of 4 hands-on labs, you will build such as a system using Microsoft Azure and Microsoft Cognitive Service. Specifically, you will use an Azure IoT Hub to ingest streaming data from simulator camera, Azure Storage to store photographs, Azure Stream Analytics to process real-time data stream, Azure Function to process output from Stream Analytics, Microsoft Custom Vision Services to analyze photographs for polar bear, Microsoft Power BI to build a dashboard for visualize results, and Azure SQL database as a data source for Power BI. In this lab, you will create a storage account and an IoT hub and write a Node.js app that connect them to a simulator camera array. Then you will test one of the virtual camera by having it upload a photograph to block storage and transmit an event containing the block URL and other information to the IoT hub. Who am I? I am Microsoft MVP trainer, speaker, and also certified in Microsoft Azure. Other than that, I am also co-organizer of Malaysia Mobile.net developer group. If you want me to have a session in your user group, please contact me. I will share my contact in the last slide. For today's objective, you will learn how to create an Azure Storage account, create an Azure IoT Hub, make authenticated call to an Azure IoT Hub, upload image to Azure Blob Storage from an app or device. For prerequisite, you need to have an active Microsoft Azure subscription. If you don't have, please sign up for free trial, the Azure CLI, and Node.js. Here is today's first lab. Okay, let's go for demo. Okay, at first you need to go to your Azure, open the Azure CLI that I already created, and add Azure -v to make sure I install the latest version to check the version of my Azure. Okay, now the next task is to create a resource group to hold the storage account and other Azure resources that make up the solution you are building. Execute the following command. And for create dashboard name streaming lab. That's RG2. Why I put RG2? Because I will create one view. And status location South Central. Okay, success create. Then we type another command. Now use the following command to create a general purpose storage account in the streaming lab resource group. And then storage account create such as name, account name, I will put demo lab, and such as resources group, resources dash group, streaming lab dash rg, such as location, so South Central US, and structure kind as the storage SS SKU and standard now RS. Okay, it's running. Okay, all is success. Before you can upload blocks to a storage account, you must create a container to store them in. Use the following command to create a container names photo in the storage account. Is that store storage container, create such as name, photos, such as an account session, then account name we put demo lab if I'm not mistaken. Okay, now we need to create an Azure IoT Hub. Azure Stream Analytics supports several types of input, include input from Azure IoT Hub. In the IoT world, data is easily transmitted to IoT Hub through few gateways or cloud gateways. And a single Azure IoT Hub can be handle millions of events per second from device spread throughout the world. IoT Hub supports secure two-way communication with the device connected to them using a variety of transport protocols. Use the following command to create an IoT Hub in the same region as the storage account you created in the previous exercise and place in the streaming lab resources group too. Okay, as that IoT Hub create slash name, we give a hub IoT Hub name demo lab hub and slash ISO resource group streaming lab dash rg2 location South Central US dash SKU and F1 and enter. Then now use the following command to retrieve a connection string for the IoT Hub. Okay, never mind. Okay, let's check the IoT Hub create such as name demo that hub streaming STIM streaming lab RG2 such as location as a source and try as F1. We can change to S1. Let's try. Oh, I know why already. F1 means that parameter SKU F1 parameter configure the IoT hub to use the free F1 pricing tier, which support up to 8,000 events per day. However, Azure subscriptions are limited to one free IoT hub each. If the command fails because you have already created a free IoT hub, specify SKU S1 instead. The S1 tier is greater expands the meshes per day limit, but it's not free. Okay, rating. Okay, while waiting, we still got a last comment to type. Okay, we're running the Node.js. At first, you need to create a folder for your project. Then, okay, let's see the last one already create. And now the Azure IoT Hub show connection string, the shared name, and demo lab hub. Okay, remember to copy this one, the connection string. And for me, let's just proceed just now to deploy the simulator camera array. The device that transmit events to an Azure IoT hub must first be registered with that IoT hub. Once registered, a device can send events to the IoT hub using one of several protocols including HTTPS, AMPQ, and MQTT. Call must be authenticated, and IoT Hub supports several forms of authentication as described in Control Access to IoT Hub. At first, run the Node.js command prompt and redirect to your folder. You must create one folder. I create a C Node project. And at first, you need to type 3 commands, execute the following command in sequence to initialize the project directory to host a Node project and install a jar of package that Node can use to communicate with Azure IoT Hub. npm initial -y. Then the second one is npm install Azure IoT Hub /safe. And the last one is npm install Azure IoT device MQTT safe. The Azure IoT Hub package provides APIs for registering device with IoT Hub and managing device identity, while Azure IoT device and Azure IoT device MQTT enable device to connect to IoT hub and transmit events using the MQTT protocol. Inside the folder, you need to create a device.json. No need worry, I will share the tutorial in this video. Let's open. Okay, the file defines 10 virtual cameras that will transmit events to the IoT hub. Each camera contains a device ID, a latitude and longitude specify the camera location, and an access key for per device authentication. The key values are empty for now, but that will change once the cameras are registered with IoT hub. Then second, we create a JavaScript deploy.js with a same folder. The code register all the simulated device defined in device.json with the IoT hub that you created earlier. It also retrieves from the IoT hub the access key created for each device and create a new file named camera.json that contains the same information as device.json but with value assigned to each device key property. It is this key which is transmitted in each request that enable device to authenticate to the IoT hub. Okay, return to the Node.js. Okay, now we need to type a Node.js deploy .js. Then after that, we go back to command prompt to type in IoT device list // hub name and hub name will be demo lab hub. Okay. It will not show you anything. Okay. Go to your resources that I download the photo of the polar bear and wolf, winter wolf, and go back to your Node.js. Then now we need to type in command prompt our terminal windows with the project directory as the current directory. Execute the following command to install the Microsoft Azure Storage SDK for Node.js. npm install, this one. Then you need to create a file again, test.js, and I open with code writer. In this code outlook the file name image19.jpg from the current directory photos subdirectory to the storage account photo container. Then it open a connection from Polar Camera 003 to the IoT hub using Polar Cam 003 access key and transmit a message containing JSON payload over MQTT. That message includes camera ID, latitude, and longitude. The URL of the blog was uploaded and the event time. Now we type a new command as not.test.js. Then after that, we go back to Azure portal that I have created before. Okay, you will see a result. You go to resources group. Then you see the streaming lab resource group that I created before. I should show you MSFD imaging. Then select a block. Then select photo. Image 19. Then you can download it. It will show you the image 19 already transfer from the IoT devices. In this lab, you created an Azure IoT Hub, register an array of simulated devices, and sends a message to the IoT Hub from one of the devices to confirm that everything was set up correctly. You also created an Azure storage account and a block container inside it, and demonstrated that a device simulated in software could upload block to it. You may now proceed to the next step in this series, processing IoT data in real time using stream analytics and machine learning part 2 to create Azure Stream Analytics job and connect it to the IoT Hub. That's all for today. If you've got any question, please send me a message through my Twitter and also follow my Twitter. And also, lastly, you can please subscribe my YouTube channel. I will share more about machine learning and also deep learning. That's all for today. Thank you very much. Okay, hi everyone. I'm Sun Jia, Microsoft MVP. Today we came to part 2 of 4 about stream analytics and machine learning. Who am I? I am Microsoft MVP, as I mentioned before, trainer and also speaker. Other than that, I am certified in Microsoft Azure, and lastly, I am co-organizer of Malaysia Mobile.net Developer Group. For today's objective is create a stream analytics job and test query on sample data stream. Run a stream analytics job and perform query on live data stream. Use an Azure IoT Hub as a stream analytics input. Use an Azure function as a stream analytics output. 4 prerequisites. An active Microsoft Azure subscription. If you don't have, please subscribe one and sign up for free trial. And other than that is Node.js. In this video, the second of 4 in the series, you will create an Azure Stream Analytics job and connect to the IoT Hub you created in the previous video. Then you will write an Azure function to receive the output and use the two of them together to analyze data streaming in from a simulated camera array. Before we go for demo, I need to let you know what is Azure Stream Analytics. Azure Stream Analytics is a cloud-based service for ingesting high-velocity data streaming from device, sensor, application, website, and other data sources, and analyzing the data in real time. It supports a SQL-like query language that works over dynamic data stream and make analyzing constantly changing data no more difficult than performing query on static data stored in traditional database. With Azure Stream Analytics, you can set up jobs that analyze incoming data for anomalies or information of interest and record the result. Present notification on dashboard or even fire off alert to mobile device. And all of it can be done at low cost and with a minimum of effort. Scenarios. For the application of real-time data analytics are many and include fraud decision, identity thief protection, optimizing the allocation of resources, clickstream analysis on website, and countless others. Having the ability to process data as it comes in rather than waiting until after it has been aggregated offer a competitive advantage to business that are agile enough to make adjustment on the fly. Okay, let's go for demo. Okay, go back to your portal.azure.com. The first thing what you need to do is create a stream analytic job. At first, you need to go to create resources, select the IoT Internet of Things to create stream analytic job. This one I will create and I discard it. You can go for it. And I go back to my all resources, stream analytic labs. Then you can see it's already created polar bear analytics. And we click this one, and you'll see this because at the end it will be here. Okay, get the input, the camera input, we add the stream input. As a IoT hub. Then after that, you can see that it's a camera input. This is the setting. Now we need to prepare the query. Because this one, query, this one, I need a query. After you upload it, you need to add a query. Then select the camera input and upload sample data from file. You no need to worry, I will share the tutorial later at below of my video. After upload, you need to test whether okay. As a test, upload sample data file. If I'm not mistaken, upload a sample data file. Okay, correct. Okay. Then how we test? The data already upload to the stream camera input and test it. Okay, it will show you the 50 row of result. The data contains 50 rows, is representing an event transmitted to the IoT hub by one of the cameras in the camera array. Okay, we can test other. Other than that, other query you can use, you can follow my tutorial. Okay, now we need to go to the Azure functions. we need to create Azure function resources. Here resources and check for Azure functions. Okay, sorry. Function app. Yeah, so the first one, then create it. After you create, you will see the Azure function, stream analytics lab 2. And you just click one. If you don't have, you add the function. Then after that, save and run the input this function, this index.js, save and run it. Okay, now we go to the output of the stream analytics, polar bear analytics. Then we need the output. Then we add. Then we select Azure functions. Then new as a function output. Then after that, you can run the polar bear analytics and start it. And now and click start. And you start the streaming job. Okay, how to analyze the live data stream? At first, go back to your previous project. Your previous project is not the project. In the first video, we create a run.js. And also no need to worry. I will share the file and share the tutorial to you at the video below. Okay, after that, open your Node.js command prompt. Open the command prompt or terminal windows and cd to the project directory. Then run the command not run.js, not run.js. Confirm that you see the similar to the following. Indicate that 10 cameras are connected to the IoT hub. After a few seconds, additional output appear. Each line corresponds to an event transmitted from a camera to the IoT hub. The output will look something like this. Confirm the camera. Okay, now I close this. Okay, you have confirmed that Stream Analytics is receiving the input from the IoT hub and that Azure function is receiving input from the Stream Analytics. The next step is build machine learning model and invert it from the Azure function, which is exactly what you will do in the next video. In summary, in this video, you created a stream analytics job connected to the IoT hub for input and connected it to and Azure function for output. You also learn how stream analytics queries are used to extract information from temporal data stream. You may now proceed to the next video in this series, processing IoT data in real time using stream analytics and machine learning part 3 to create a machine learning model and connect it to stream analytics. That's all for today. If you got any question, you can message me with my Twitter, and remember to subscribe my YouTube channel. If you got any question, you can comment at my video below, or you want to listen more about AI or machine learning, also let me know. You can put a comment as below. That's all for today. Hello, testing. Hi everyone, I'm Ingest, Microsoft MVP. Today we came to part 3 of 4 stream analytics and machine learning. Today we will cover the cognitive services. Who am I? I am Microsoft MVP, trainer and also speaker. Other than that, I am certified in Microsoft Azure. Other than that, I am co-organizer of Malaysia Mobile.net Developer Group. For today's objective, we use the custom vision services to train an image classification model. Test a custom vision services model. Call the model from an app or services. For prerequisite, an active Microsoft Azure subscription if you don't have signed up for a free trial, and also the Azure CLI. Azure CLI refers to command line interface. And here we came to a predict. Use Microsoft Cognitive Services to predict the result. Before we go in, I need to introduce about Microsoft Cognitive Services. Microsoft Cognitive Services is a suite of services and APIs backed by machine learning that enable developers to incorporate intelligent features such as facial recognition in photo and video, sentiment analysis in text, and language understanding into their application. Microsoft Custom Vision Services is among newest member of the Cognitive Services suite. It's supposed to create image classification model and learn from label image you provide. Want to know if a photo contains a picture of a flower? Train the custom vision services with a collection of flower image, and it can tell you whether the next image includes flowers or even what type of flower or it. The custom vision services explore two APIs: the custom vision training API and custom vision prediction API. You can build, train, and test image classification models using custom vision services portal, or you can build, train, and test them using the custom vision training API. Once a model is trained, you can use the custom vision prediction API to build app that utilize it. Both are REST API that can be called from a variety of programming languages. In this lab, the third of 4 in the series, you will create a custom vision services model and train it to differentiate between various types of artist wildlife. Then you will connect it to the stream analytics job you created in the previous lab. Let's go for them. Okay. Okay, first go to customvision.ai and custom vision. add a new project. I already create a polar bear project. Then after that, you add all the image about the active fault, polar bear, and walrus. No need to worry about it. I will share the video, the where to get the image. I will put the tutorial below my video. After that, you will train the model using the image that you take and upload in the previous exercise. Then you will test the model to determine how adept it is at identifying artist wildlife photo. Training can be accomplished with a simple button click in the board or by calling the train project method in the custom vision training API. Once trained, a model can be redefined by uploading additional tag image and retrain it. Okay, at first we go to training image, then we select performance. Okay, here it shows the precision and recall are separate but related measure of the model accuracy. Suppose the model was presented with 3 polar bear image and 3 walrus image, and that it correctly identified 2 of the polar bear's image as polar bear image, but incorrectly identified 2 of the walrus image as polar bear image. In this case, the precision would be 50%, while recall would be 67%. You can learn more about precision and recall from the precision and recall inside the Wikipedia. Now you can take a quick test whether it's accurate or not about the local file. Change image. Let me change image. Walrus. Okay, the polar bear is the higher probability, and the walrus is 0%. Okay, now I close this one and go for performance. And prediction we make at default. Then we get the prediction UI. Remember this, your prediction API and also the prediction key. Okay, now we go back to the Azure portal. Then at first we select this one, the Azure CLI Cloud Shell. At first we enter this one, the first command. You need to set your admin username and also the password. The second command you need to type is this one, this command. Then streaming lab server, that is your database name, server name, and this one is your database name. Okay, after that you need to go to a firewall, do anything. Okay, firewall and virtual network to click save. Click allow access to Azure services, then click on, then save it. After that, you go to the query editor. I think not here. Nothing here. Lab. That's a chat. Okay, here. And log in with your username and password that just now you create. And click OK. Then create a one table. I already create one table with the name of DBO, the polar bear. That's this one. Okay, now it's already success grade. Now we go to Azure function. You will modify the Azure function that you created in the previous lab and call custom vision services and determine the likelihood that an image that might contain a polar bear does contain a polar bear, and to write the output to the Azure SQL database that you created in the previous exercise. This one. Then you select this one, then go to platform features, select the console, enter the npm install request. Waiting. Okay, another one, npm install tedious. And while waiting, the last command is the type the npm install Azure storage. Azure function writing in JavaScript execute in the Node.js environment. The function console gives you access to the environment and let you install npm package the same as you would look in a local environment. Okay, the last one, npm install Azure storage. Okay, the three command is about install the npm request package, the npm disk package and the Azure Storage SDK for Node.js, so your function can use them and ignore any warning messages that are displayed. Okay, now go to Azure function that you created in the previous lab in the Azure portal. Go for see previous lab. Replace the function code with the following code. Okay, we open the Node.js. Node.js and also my code editor. And Node.js. Okay, just now we need to write a new run.js. I will share the file with you. This is your prediction URL, prediction key, store account name, store account key, database server, database name, database username, database password. Then after that, we cd desktop and cd to node project. Then I need to execute the command. Node run.js. Okay, that's all for today's demo. In the next lab, you will use Power BI to produce a more compelling and graphical visualization of the data. In this lab, you use the custom vision services to train an image classification model that can differentiate between different types of Arctic wildlife. Then you modify the Azure function you wrote in the previous lab to call the model and write the result to an Azure SQL database. You may now proceed to a final lab in this series, processing IoT data in real time using stream analytics and machine learning. Part 4. To apply the finishing touch by building a live dashboard that shows where polar bears are being spotted in the wild. And here with my Twitter, you can follow my Twitter and also my YouTube channel. I will try to publish video bi-weekly. If you want to know other Microsoft technology about AI, cognitive services, test analytics, cognitive services, machine learning, deep learning, and cognitive toolkit, please let me know. That's all for today. Hi everyone, I'm Ingest. Today we came to the last part 4 of 4, stream analytics and machine learning. Who am I? I'm Microsoft MVP, trainer, and also speaker. Other than that, I am also certified in Microsoft Azure. Lastly, I am also co-organizer of Virtual Mobile .NET Developer Group. Okay, for today's objective, you need to connect Power BI to an Azure SQL database, use Power BI to visualize data writing to the database, create a report that can be shared with your colleagues. For prerequisite, you need to have an active Microsoft Word or School or organization account, an active Microsoft Power BI subscription if you don't have sign up for free trial. Okay, in this lab, the four in a series, you will connect Microsoft Power BI to Azure SQL database you created in the previous lab to capture information emanating from the virtual camera arrays you deployed in the ArcGIS. Then you will use Power BI to view a report that shows in near real time where polar bears are being spotted. The goal of business intelligence is being able to quickly identify and respond to ever-changing trends in business and industry. Whether you are data analyst, deliver reports and analytics to your organization, or a stakeholder or decision maker in need of critical insights, Power BI can organize and unify all of your organization data to provide a clear view of the world around you. Microsoft Power BI was created to address the data explosion in commercial and academic organizations. The need to analyze that data and the need for rich interactive visual to represent the data and reveal key insights. It contains a suite of tools that assist in data analysis, from data discovery and collection to data transformation, aggregation, sharing, and collaboration. Moreover, it allows you to create rich visualization and package them in the interactive dashboard. Okay, let's go for demo. Okay, at first, you go to the Power BI service portal at https://powerbi.com. If asked to log in, do so with your school or organization account. There are two types of Microsoft account: personal Microsoft account and work school account, also known as organization account. Power BI accepts the latter but not the former. If you have an Office 365 subscription, it uses your work or school account. You can have a work or school account without having an Office 365 subscription. However, for an explanation of the difference between personal Microsoft account and work school account, see you can search for understanding Microsoft Word and personal account. At first, you came to here, the dashboard, then you select the data, then you select the database, then you select the Azure SQL data warehouse, then it will connect you to your previous lab, the SQL database that you had created. After that, it will show you a Power BI dashboard. This one I already create, and I can direct go to there. Then you will see this one. You can use any of the things, tools. Then Earth, I need to have Earth. Then I need to have a longitude and latitude. If longitude and latitude we cannot put average, yeah. You need to say non-summarize, and latitude we also non-summarize. Then the map will be show. Then you put is polar bear. You want no artist at where, because it does not zoom it for me. Then after that, you also can drag and drop the card. Drag and drop the card. I think value, no need. This one you can directly delete, or you can put a table that show the camera ID, and the longitude and altitude. I think the longitude and latitude got some problem. We can remove if we don't want. Then camera ID, then they show that got polar bear. If because I see my data is incorrect, if correct, it will show you here. Then after that, you can show the number. If you want to change like just now, I need to get a blank space and put back the table again. Okay, you can see that my demo is incorrect. Does not show any data and the map, but you can follow my tutorial as below. That's all for today. Okay, let's summarize. In a series of 4 hands-on labs, you build a solution that fits data from a simulated array of cameras into an Azure IoT hub, upload photographs to Azure storage, process the data using Azure Stream Analytics, analyze the photograph using the custom vision services, and visualize the output using Microsoft Power BI. You also got first-hand experience using Azure Function and Azure SQL database. It's a sophisticated solution and one that has application in the real world. When you have finished, okay, that's all for today. Here is my Twitter. If you got any question, you can message me in my Twitter. Other than that, please subscribe my YouTube channel. If you want to know more about other Microsoft technology, you can share with me. Maybe I can invite others to join my YouTube channel to talk about the technology. That's all for today. Thank you very much.